Okay, relations and functions. I think by now we know the definition of a function. A relation in which each element of the domain is paired or mapped with exactly one element in the range. Okay, we need to define one-to-one function and onto functions. We can see this is one-to-one, but this is not one-to-one. Notice we got two things, R and B, both map to 3. But over here, each thing in the domain goes to one thing in the range. And so that's our definition. One-to-one means each element in the domain maps to a unique element in the range. This over here is still a function, it's just not one-to-one. Over here, we have a function that is one-to-one. Now onto, this is not onto. We just have things I think about it as there are things in the range that don't get used. Everything in the range here gets mapped to. Over here, not everything does. So each element in the range corresponds to an element of the domain. Everything in the range is used. Okay, so let's look here. State the domain and range of each relation, then determine whether each relation is a function. If it is a function, determine if it's one-to-one, onto, both, or neither. Okay, so the domain is just all the x's. These are all inputs, outputs, input, output. If I put a -3, I get out -7. Put a -1, I get out +7. Put in 6, I get out -9. So the domain is all your inputs, -6, -5, -3, -1, and +6. Our range is all our outputs. -9, -7, -1, and 7. -9 happens twice in our range, but you only have to write it once. It is just a single element. It just gets, something goes to it, two different things go to it. Is it a function? Yes. No x. -6 only goes to -1. -6 doesn't go anywhere else. -5 only goes to -9. -3 only goes to -7. -1 only goes to 7. 6 goes to -9. I know you've probably done it in the past where it's like you say, well, the x's don't repeat. Fair. So yes, each element in the domain maps to exactly one element in the range. Now, is it one-to-one? Well, as you can see, -5 goes to -9, and 6 goes to -9. So no, both -5 and 6 map to -9. So each element in the domain does not go to a unique element in the range. Still a function, because they can go, multiple x's can go to a single y. That just means it's not one-to-one. Is it onto? Does everything in the range get used? And that's yes. Every element in the range corresponds to an element in the domain. At least one element in the domain. Okay, in the good old-fashioned, are they a function or not? You can use the vertical line test. This is obviously a function. Here, if I plug in 3 for my x, I get out 2 and -2. So 1x gives me 2 y's. That's a no. Here, -1 only goes to 1, 0 only goes to 3, 1 goes to 2, 2 goes to only to 1, and 3 only goes to 3. So yes, that's a function. Here I can see down here, this doubles up. 1 goes to 1 and 0. So no, that's not a function. And for the record, this is onto, I'm sorry, one-to-one and onto for that matter. The entire range is used, and there's no x that goes to more than one y, or I'm sorry, no y, no 2 x's go to the same y. That's what I'm getting at, I'm sorry. So here, this is not a function anyway. Here, this is one-to-one because nothing gets mapped to two different things. And there you go. That is it. That's all this lesson was about. Good luck.